All right, let's talk about average rate of change and linear equation forms that we're going to use in calculus. So I have the situation, the cost to manufacture a given product in 1990 was $35. And we're going to go ahead and let x equals 0 be year 1990. So that's important right there. The table below shows the cost, y, to manufacture the product at other specific times. So two questions I want to try to answer here. One is, what was the average rate of change in cost between 2003 and 2007? All right. So when we're talking about an average rate of change, that's different than an instantaneous rate of change. And calculus is all about the instantaneous rate of change, but it is based on average rate of change, which is basically a slope. So to find slope, we know that the slope is defined as the change, back up here, it is the change in y divided by the change in x. So when we're talking about an average rate of change, that is truly a slope. So 2003, we need to figure out where that is in the table. Well, back up top, since 0 represents 1990, then we know that we're looking at an x value of 13 for 2003 and an x value of 17 for 2007. So from the data that we have, we can go ahead and subtract those. So as long as we're consistent, we're fine. So we could do 112 minus 90 divided by 17 minus 13. So 112 minus 90 gives us 22 over 4. And when we divide that out, that gives us $5.50 per year. That is the average rate of change. And we've got it labeled appropriately as well. Now, the second part of this prop, which 8-year time span showed the greatest change in cost. All right, so basically what we've got to do is we've got to look at the table and think about 8 years. Well, from year 1 to year 9, that's 8 years. So from 40 to 88, it looks like that difference right there is 48, okay? So let's do that again, and you'll notice that the table worked out kind of nice, that 5 to 13 is also 8. And as is 9 to 17, as is 13 to 21, as is 17 to 25. So basically what I have to do is I just need to look at these gaps here between every other set of numbers and figure out which gap is the largest. Okay. So, taking a look at what I have, again, the gap between 40 and 88 was 48. The gap between 84 and 90, well, that's only 6. 88 to 112, that's 24. 90 to 144 is 54. And 112 to 168, that is 56. So I think we found it. It's going to be 17 and 25. But it says which 8-year time span. So I need to be specific and say which years those are. And so let's see. If I'm 17 from 1990, that would be 2007. And if I'm 25 years away from 0, which is 1990, that's 2015. So during that 8-year time span, that's the greatest rate of change. All right. So the last thing with linear equations is we can use a couple different forms with linear equations. One is slope-intercept form, one is point-slope form. Okay. So if we're thinking about forms, slope-intercept form, y equals mx plus b. Point-slope form, we're talking about the quantity y minus y1 is equal to m times x minus x1. Okay, so let's kind of look at let's look at those. Okay, and the situation that we have. All right, So if we were to write this line in point slope form, we can just do y minus the y value, which is -1, and set that equal to the slope 2/3 times x minus 6. Okay, so that's point slope form, and a lot of times on AP, point slope form, it's just fine. It's a form of a line. Okay. But if we simplify this and convert it to slope-intercept form, this would be y plus 1 is equal to 2/3 x, and 2/3 times -6 is -4. So this would be y equals 2/3 x, and if I subtract 1 over, I've got -5. So point slope form, slope-intercept form. Okay, either is fine. I kind of like to do a slope-intercept form, especially if we're dealing with graphs. But again, kind of a preference for you. So we'll do either. So if we were just to start with finding the y-intercept or the b value in slope-intercept form, let's go through that process here. So that process would be y equals the m times x plus b, which is unknown. So if I put the y value in, -1, and the 6 in for the x value, I get -1 equals 2/3 of 6, which is 4, plus b. And if I subtract 4 from both sides, I get b is equal to -5. Therefore, y equals 2/3 x minus 5. And you'll notice that is the same as we have over here. And it should be. So that's a look at average rate of change. Remember, that's a slope. And as far as formatting linear equations, generally we're going to do probably slope-intercept form, but point slope form is A-OK as well. Thanks for watching.